Okay, lads, I hope you're all keeping well. I'm going to take you through the answers to this circle theorems assignment, which was tricky, and there were a good few people who had messaged me about problems they were having, etc. I suppose the difficulty with this type of question is you might know the theorems, okay, by looking at the video, but it's how to apply them. So it's, knowing where to, which theorem to use and which angles you have to find, etc. And it can be quite complicated. But as I said to you before, sometimes you have to find angles in the actual diagram that you're not asked for, and that'll lead into finding another angle and it'll help you out. So you may have got on alright on it, you may have struggled with a few, but what I want you to do is watch the video closely. You might have to watch it a couple of times, 2 or 3 times. Go through your answers, check what you've done, understand the reasoning and how I'm explaining how I do them. For the rest of this week, I'm going to be setting you more circle theorems exam questions to complete, so you should become better at them as the week goes on. So I'm going to set you an assignment for this Thursday and Friday, and it's to be finished then for Monday next week. But let's look at some of these and we'll discuss them, and then if there's any further issues, you can message me and then we can try to sort the problems out. So in the diagram, you've got this set up here, okay, and there's a number of things going on. From what I can see is you've got this is an external point, so these two lines are equal in length. This is the center, so this is going to be 90 degrees because, and so is this here, because you've got a tangent and a radius, they're meeting at 90 degrees. You've also got a Star Trek symbol, which means that this angle up here, okay, and this one, they're doubled. So see that, I'm going to mark them. If that angle is double that one. And also that goes in reverse, where this angle here, which I'll mark with a double line, is double that one. Okay, so there are all things that you need to be aware of just by looking at the diagram first of all. So I'm going to call that X, and that'll be 2X in there, and that's going to be 2Y that, and that's going to be Y in there. But anyway, without putting the letters in, let's check out a couple of things. And first of all, that is X, that is 90, and that is 90. Now you're asked in the question to work out the size of the angle SPQ in terms of X. SPQ is this angle in here that I'm going to colour in black. See that angle in there? That one. Right? Now, I know that that one, right, if you double it, you get this one here. So I'm going to try and find this angle in terms of X, and then if I half it, I'll get this one in here. Now, in order to get that, I'm going to look at this quadrilateral TSOQ. I'm going to draw it out. Draw it out like this. So there's T, there's O, there's S, and there's Q. We know those are both 90 degrees from the diagram. You can see them. And we know this is X. Now, in a 4-sided shape, the angles add up to 360 degrees. Sorry, I'll move that up so you can see it. I've drawn that out, sorry, SOQT, okay, from the diagram. That's X, that's 90, and we know it's a 4-sided shape and they add up to 360. So if you add 90 and 90, you get 180. So this angle in here is going to be 180 minus X. The reason why is because those two add up to 180, then these two must add up to 180 because they add up to 360. Okay, so this angle is 180 minus X. So see in here, okay, I can say that that is 180 minus X. See that angle in there? All right, this one. Now, what I can do is, there's a couple of ways I can look at this, right? I can then say, using the Star Trek symbol here, that if I half that, I will get this angle at the top here. See this angle up at R? So if I half this, I get 90 minus a half X. That's going to be that angle in there. See there? 90 minus a half x. Now, what I've got is I've got a cyclic quadrilateral or SPQ. Do you see it? Or SPQ. So this angle and this angle, remember opposite angles in a cyclic quadrilateral will add up to 180. So this one that I'm looking, which is coloured in, and this one, which is 90 minus x, are going to add to 180. So in order to get this one, which is coloured in, that's the angle SPQ, which is the one we're looking, I'm going to have to say it's 180 take away this angle. So I'm going to write SPQ equals 180 minus 90 minus a half x. Okay, so how do I do this? Well, then I'm going to have to take this away. Remember, when you've got a minus, that's going to be a plus. So it's going to be 180 minus 90 plus a half x. So it's 90 plus a half x. I'll write that down below. 90 plus a half x. That's going to be the angle there at P. 90 plus a half x. So to run over that again in case you're confused, that was x, that's 90, that's 90. So this is 180 minus x. See this angle here that I'm going to colour in, shaded in there, that angle SOQ, that's 180 minus x, because these two must add to 180, because these two are both 90 and a four-sided shape, the angles add to 360. If this is 180 minus x, if you half it, you will get this angle at the top, which is 90 minus a half x. And then because of a cyclic quadrilateral, we know that this angle and this angle will add up to 180. So this angle is 180 minus this 90 minus a half x, which I've done the working out here, and you get 90 plus a half x. So that's the answer for the first one. Tricky enough question to start. Okay, let's look at the second question. A couple of things that you need to be aware of that we can work out, and they're missing angles in here. The first one I'll say to you is there's 65, there's a chord, there's a tangent, there's 65. So using the alternate segment theorem, this is 65. Okay, remember the angle between a tangent and a chord is equal to the angle at the top of the triangle. Now these two angles and this angle will add up to 180, so I can then use my calculator to go 50 plus 65 minus from 180 is 65, so this angle is 65. Now if you look at this chord and this tangent here, 65 means this is also 65. So it's actually an isosceles triangle, that. Now, I can tell that these two lines are parallel. I'll put arrows on them. Because the 65 and this 65, which I'm going to colour in, see that one there and this one here, they lie in a Z. Follow the pen. Up, down, up. See the Z shape? Which means they're alternate angles. So if you want to justify your proof, here's how I would say it, okay? First of all, here's the answer perfectly laid out. The angle TAB is 65 degrees. Therefore, that's this angle in here, therefore the angle BCA is 65 degrees. And that's using the alternate segment theorem. That's that angle in there, right? Now, we also know that the angle CAU is 65 degrees. Therefore, the angle ABC is also 65 degrees. And that's using the alternate segment theorem. Because these two angles are equal, right, we can see that there's a Z here where TA and CBA are alternate, right? So TAB, and that's that angle, and angle CBA are alternate. Therefore, the line BC is parallel to TU. Okay, you write that out in the exam, you're getting full marks. That's the way it works. So you had to use the alternate segment theorem. 65, that's 65. 65 and 50 is 115. From 180 is 65. So that means if that's 65, then the angle at the top of the triangle is 65, and these lie on a Z. Okay? You can see there's also another Z here, 65. There's another Z. Okay, so it is parallel. Right. Shifting on to the next one. Let's fill in some missing angles to help us, okay? Right, and this will help us. This is going to be, because this is a diameter, this is going to be 90 up here, okay? This is going to be 72, they're vertically opposite. If you take 72 away from 180, right, you end up with 108. So that's going to be 108 in there. Those are radii. See all the radii in there? Remember I said to you about isosceles triangles, so you need to be careful. Because they're radii, it means that, you see 72, these two angles are going to be equal. See those two? Because you've got an isosceles triangle, because this and this line is the same distance. So 180 minus 72 divided by 2 is 54. That's going to be 54. That's going to be 54. That's also going to be 54. Because from a chord, if you draw the same line, it's 54. And this is also going to be 54 up here. Okay. So we've plenty of angles we can work from. So let's look at it and see what we're asked for. Work out TBO. TBO is 90 because that's a radius and a tangent meeting at 90 degrees. CAB, well that's going to be 90 minus 54, which is 36. That's going to be 36. Okay, the next one is work out CBW. So CBW, well that's going to be 90 minus 54 because CBW is this angle in here. Okay, and remember a radius and a tangent meet at 90 degrees. We know this is 54, so that's going to be 36 as well. And then work out DBC. Okay, DBC is 54. We've already worked that out from the diagram. Okay. Next question is, I'll just zoom out a wee bit here. We can see. Next question is number 6, right? And we'll fill in some missing angles that will help us here. First of all, this is 90 degrees. See in here, that's 90 because that's a diameter in there, and that's a right angle triangle. So if you take 46 away from 90, you end up with 44. That's going to be 44 in there, that angle in there, right? This is 46, which means if you double 46 is 92. There's your Star Trek symbol, that's 92. Right, this angle, if you look at this chord UT, this angle is 36, which means this angle in here is also 36. See in there? That's 36. We also know that this angle we can work out because this triangle is 46 and 36, which is 82, and that leaves 98 in here. And it leaves that as 98 because they're vertically opposite. We know this lies on a straight line. So that's going to be 82 in there. And that's going to be 82 in there. So just working around the houses. We can work out this angle because 36 and 98. Okay, we'll add those. take that away from 180 and we get 46 in there. So look, I've been round there and I've been able to work out a few things. There's other things I can work out that I've missed. See that there angle in there? If I take 92 away from 180, I get 88. That's 88 in there. And 88 and 82 away from 180 leaves me with 10 in there. So look, I've filled in loads of the angles just by going around and fixing it. So let's see which ones are asking me for. Work out RTS, that's 46. Work out ROS, that's 92. Okay, shift the page up a wee bit, sorry, that's 92. And work out SUT, well that's 44. Okay, SUT is 44. So look at my diagram again, and if you go through the video you'll see how I got each of those, so they're easy enough to work out. Last question then, right, let's fill in a few missing angles. What we've got is 31. Now if you use the alternate segment theorem, you can see that this is also 31 because there's a chord and a tangent, there's the angle and there's the angle at the top of the triangle. There's a chord and there's 62, which means that is also 62. See there, using the alternate segment theorem that way. Now if you add 62 and 31, you get 93. 93 from 180 is 87. So this is 87 in here. Okay. And then it's a cyclic quadrilateral. See this here, cyclic quadrilateral. So 87 and this angle up here will add to 180. Okay, so you're getting 93 in there. 93. So let's look at to see what they're asking. Work out the size of the angle FGH. FGH is going to be 62. And work out the size of the angle DEF. Well, that's going to be 93. Okay. So take a check at the questions. They are hard, right? There's no doubt, especially the first one where there was an X in it. But look at it a couple of times. You may have to replay the video a couple of times in order for you to see what's happening. And if there's any problems, sure, let me know. But I'm going to be posting up maybe 6 questions on circle theorems for you to complete for the end of the week. So I want you to look at them closely, and they'll challenge you, okay? But again, they're good questions. Sometimes you need to find missing angles that you're not asked for, so complete the diagram. It's like a wee puzzle. Complete the diagram and then you should be able to work out missing angles that you need. Hopefully everybody's well. Remember to keep up to date with the work. I keep saying that because I have to award you a GCSE grade at the end of the year, and it has to be based on evidence. If you look at the news, that's what's been stated, that you can't just give grades out without evidence from the pupils. So I will be referencing work that's been completed on Google Classroom, assignments that have been handed in, the quality of work, etc. So if you're not up to date and your work isn't good and you've missed work, etc., then that's going to have a detrimental effect on your grade. So make sure you're up to date. Hopefully everybody's well. Any problems, just post me a message. Thanks. Bye.